Okay.
Okay. Now this is a 24-volt system. If you use 12 volts, then for the same power, which is volts times amps, you've got to have twice as many amps if you have half the volts. So, if you have twice the amps, you can lose a lot of power by heating up cables.
Okay.
By the square of the increase in amperage. So, I use 24 volts. Here's a 6-volt battery, plus, minus, which is connected to the plus, to the minus. That gives 6 more volts, which is connected to the plus, to the minus, giving 6 more volts. Now we're up to 6, 12, 18, to plus and to minus, which gives us 6, 12, 18, 24 volts. See?
Yep. Okay.
Okay. So from each one of these arms is at 24 volts. And then from this arm, the same thing. 6, 12, 18, 24 over to this arm. Okay? And then from this one, the same thing. 6, 12, 18, 24 over to there. And there's 2 more full sets. So there's 5 full sets. And these are in series, so they add up. 6, 12, 18, 24. Each one of these. But they're in what they call parallel. You got a set here, another one here, another one here. And so they're all 24 volts, but all of the negatives are tied together, and all of the positives are tied together. So that gives you 24 volts, but 5 times as much capacity as if you had just one of these sets. And they feed through these huge cables.
Mm-hmm.
That's called double aught,
Okay.
00 gauge cables. They're real heavy, and they go to this switch. And the switch is on at the moment, so it is feeding electricity to this, but this is off at the moment. But it is telling me what the voltage is. 25, 9, 26 volts, so it's overcharged really. Because the...
Well, then we can use the vacuum cleaner.
Huh? Well, we can use it sometime. No, I found that... Careful, don't bump against wires.
Yep.
I found that one of the cables had a loose screw on it, so it wasn't producing electricity, so we've been a little short over the last few days. But actually, a 6-volt battery really is supposed to be 6.4 volts at full charge. Multiply that by 4 in series, and it gives you 25.6 volts. And this isn't 25.6, it's 25.9, so the batteries are actually overcharged
Okay.
by 0.3 of a volt. And this is the inverter. All of this power through this switch goes in over on this side, and, well, it goes on the back side, really.
Okay.
And this, when it's turned on, which you do by pushing the on-off button. See the little blinkities over there?
Yep.
That means that it's on. It's waiting for somebody to turn on a light or a vacuum cleaner or something. I just turned it off now, because if there's lightning, I don't want shocks moving around. And this takes 24 volts from the batteries,
Okay.
which is DC, direct current, only going from plus to minus, and converts it to 120 volts AC, back and forth AC, which is house current in the States, which comes out through these wires here.
Okay.
That one, and that one,
Okay.
that
Yeah.
one,
Yeah.
and that one, and attaches to these wires Okay,
Mm-hmm.
that's 120 volts AC, which goes into that pipe. Okay,
Mm-hmm.
the vertical pipe, which goes down underground all the way to the house, encased in plastic pipe.
Okay.
So this way I don't even have to look at my own solar panels, much less stupid telephone poles.
Okay. Thank you, Dad.
Mm-hmm.